In today's interconnected world, even CubeSats are vulnerable to cyber threats. The REWIRE project is tackling this issue head-on, focusing on enhancing the security of satellite firmware updates. Traditionally, CubeSats haven't prioritized security due to time and budget constraints, as well as limited onboard resources. However, with the increasing accessibility of radio frequency equipment, the risk of attacks on these satellites has grown significantly. These attacks could disrupt missions or even seize control of entire satellite constellations, potentially impacting critical applications. REWIRE aims to address these challenges by implementing secure over-the-air updates that won't compromise satellite availability and can be rolled back if issues arise. It also seeks to prevent replay attacks, where malicious actors intercept and reuse legitimate commands on both over-the-air updates and critical telecommands like maneuvering thrusters. Another crucial aspect of REWIRE is establishing zero-trust onboarding for ground stations. Since these stations are often owned and operated by third parties who may not be entirely trustworthy, REWIRE aims to create a trust-aware onboarding process to safeguard the network. In an as-is scenario, a satellite operator initiates an over-the-air update through a selected ground station. The ground station segments the firmware file into several frames and initiates an uplink session. Each frame is encapsulated into a CC/SDES space packet frame before transmitted. The comms subsystem of the satellite receives the frames and reassembles the firmware file. After an integrity check, it instructs the bootloader to boot at the new firmware. In general, satellites are quite compacted due to the limited space and in an effort to reduce weight. For this reason, during development, an exploded version is preferred, commonly known as FlatSat. This allows easy access to all subsystems of the satellite for quick and easy troubleshooting. For the REWIRE purposes, LibreSpace Foundation has implemented a FlatSat utilizing the SatNog's comms telecommunications subsystem and the Genesis 2 board as the onboard computer. The SatNog's comms is responsible for the communication with the ground stations, whereas the Genesis 2 board implements data handling and the integrity check of received firmware files. The communication between the SatNog's comms and the Genesis 2 board is accomplished through a simple UART interface. As reference ground station, the setup utilizes a software-defined radio. In a demonstration of the current vulnerabilities, a scenario is presented where a CubeSat operator initiates an over-the-air firmware update session. But an eavesdropper intercepts the uplink frames and gains access to the firmware. As we can see in the telemetry, the firmware update to version 1.4.1 has been successful. For demo purposes, the operator updates the firmware to 1.4.2. Again, from telemetry, we can see the update successfully completed. In a subsequent over-the-air firmware update session, the attacker can then roll back the firmware to the previously intercepted version. This same replay attack strategy could be used for critical telecommands, potentially causing significant harm. The project's next steps include the integration of the Keystone Trusted Execution environment on the demonstrated application. In addition, LibreSpace Foundation will try to integrate Keystone directly on the SatNog's comms FPGA. The demonstrated scenario will be enhanced with secure over-the-air update mechanism supporting also rollback. For the second experimentation period of the project, the focus will be on the zero-touch onboarding of the SatNog's ground stations, as well as validation of the AI misbehavior detection engine of REWIRE, utilizing both synthetic and real satellite telemetry data.